Hello friends, this is Nyamatulla and Patel, Department of Computer Science and Engineering, Hirashikar Institute of Technology. So, dealing with the subject data mining and data warehousing. Coming to the module 5, today we are going to discuss DB-scan algorithm. So, DB-scan algorithm, what is DB-scan? Density-based spatial clustering of application with noise. DB-scan is nothing but density-based spatial clustering of applications with noise. So here, whenever we are clustering a density of points or density of the objects in presence of noise, we apply the DB-scan algorithm. DB-scan algorithm is a density-based algorithm. So what is density? Density is equal to number of points within a specified radius epsilon. So here any point is taken, from that point and radius is drawn. A circle is drawn with a radius of epsilon. All the points within that radius belongs to the cluster. So density is equal to number of points within a specified radius epsilon. Okay, so now consider this is, I'll take one point and radius of this I will take it as epsilon and I'll draw a circle. Okay, so the first condition is for drawing a cluster, what we do is we take a point and we draw a circle, and with that circle what we do, we take a radius of epsilon and draw a circle. A point is a core point if it has more than a specified number of points, minimum points within the EPS. So here the condition given is minimum points equal to 4. So whenever you draw a circle, I have taken this point and I have taken a radius of epsilon, I have drawn a circle. If this circle contains minimum points equal to 4. So now I have drawn this circle, and how many points are this in this circle? 1, 2, 3, 4 and 5. There are 5 points in this circle. So this point with respect to which I have drawn a circle and taken a radius of epsilon, this circle which is having points more than 4, so now this point is called as core point. This point is called as the core point. So what is a core point? A point is a core point if it has a more than a specified number of points within the radius of epsilon. Okay, these are the points that are interior of the cluster. So now these points 1, 2, 3, 4, 5, all these are the points within the cluster. So these all belongs to this cluster. Now a border point has fewer than minimum points within EPS, but it is in the neighborhood of the core point. So which point you call as a border point? So take another point. So with this point, take this point and again take a radius of epsilon and draw a circle. And draw a circle. So once I draw this circle, so how many points are there in this circle? 1 and 2. 1 and 2. There are only 2 points in this circle which does not satisfy the criteria of minimum points equal to 4. So this point cannot be a core point. So this point will be a border point. So one condition what it is not satisfying is minimum points equal to 4. This condition it is not satisfying. So this is not a core point, but this point is in the neighborhood of this circle. Now this point is within this circle at the border point. So this point is in the neighborhood of the core point. So this point is called as the core point. Next, what is a noise point? A noise point is any point that is not a core point or it is not a border point. So which point is called as a noise point? Noise point is nothing but it is an outlier. It neither it is a neighborhood of the core point or neither it is satisfying minimum point equal to core. Minimum points equal to 4. Let us take, this is a point. It is a point I have taken epsilon, I have taken a radius and I have drawn a circle. So if this has to be core point, What is the first condition it has to satisfy? It has to satisfy minimum points equal to 4. But how many points are there in this circle? There are only 2 points, so this is not a core point. Second condition. So if it has to be a border point, it should be within this circle. So this point is not within this circle or not within this circle, or this point is not in the neighborhood of the core point. So this point is called as a noise point. So there are 3 points in DB scan algorithm. One is core point, one is border point, and one is noise point. Core point, what it has to do, it has to draw a circle with radius epsilon, radius equal to epsilon, and draw a circle, and it has to satisfy minimum points equal to 4. Then all the points within this circle are called as interiors of this circle, or they are within this circle. Then what is a border point? Again you take one more point, draw a circle with radius epsilon, and check whether it is having minimum points equal to 4. So it is not having minimum points, it is having only 2 points. So this is not a core point, but it is in the neighborhood of the core point, so this is called as a border point. Then what is a noise point or outlier? So that noise point is any point that is not either a core point or not a border point, because not a border point, because when you take this point and draw a circle with epsilon radius, it is having only 2 points, which does not satisfy this condition, minimum points equal to 4. Then it is not also in the neighborhood of this circle, so this is called as the noise points. So based on this, DB scan algorithm will grow part by part and form the clusters. Okay, so what is the strength and weaknesses of DB scan algorithm? It is relatively resistant to noise. So DB scan algorithm is relatively resistant to noise. So all the points which are outside the radius of epsilon, or that are all the points which are outside this circle, they are directly neglected. Means no noise points can be treated as interior of the circle, or they cannot be taken as within the cluster. It can handle clusters of different size and shapes. As compared to the previous algorithm, k-means algorithm or agglomerative algorithm, it cannot, those cannot handle the clusters with different shapes and size, but this will handle clusters with different shapes and size. Does not work well when the cluster having varying densities. So this is a disadvantage. Weakness of DB scan is it cannot work well when the cluster is having variant densities, and it does not work well with high dimension data. So the data, when the data whatever you are dealing, if that is a high dimensional data, so DB scan algorithm will not work. So let us take an example, DB scan example. If epsilon equal to 2, now what is given? I have to draw a circle with radius equal to 2 and midpoint is 2. What are the cluster that DB scan would discover with following 8 examples? So 8 points he has given. So now I need to find out out of these 8 points they belong to which clusters. The distance matrix is same as given, so distance matrix is already given. So draw a circle, draw a graph of 10 by 10 space and illustrate the discovered clusters. What if epsilon is increased to 10, root of 10? Before epsilon equal to 2, the radius of the circle was given 2. Next, the radius of the circle was increased to root 5. Then what happens then? So let us take the solution that what is the epsilon neighborhood of each point. Now for each point, what we need to do, epsilon, what I need to find out is there any points within the radius of 2. Take A1 point, A1 you take, is there any point? So A1, A2, A3, A4, A5, A6, A7 and A8. So these are all the distance matrix. A1 to A2 is, the distance is root 25, A1 to A3 is root 36, A1 to A4 is root 13, A1 to A5 is root 50. All these are greater than the value of 2. So this A1 will not have any points in the neighborhood of it. So A1, A2 is not in the neighborhood of A1, A3 is not in A1, A4 is not in A1, A5 is not in A1, A6 and A7 and A8. All these are not in the neighborhood of A1. Why? Because all these distance matrices are more than 2, where epsilon value is given 2, so these all will not come into in the A1's range. So N2 A1 equal to 0, null. Now take A2. Now take A2 point A2. So A2 to A2 is 0. A2 to A3 is root 37, root 18, root 25, root 17, root 10 and root 20. So A2 also will not have any points whose value is less than. So if I draw a circle for A2 with a radius of 2, all these points will lie outside the circle. So it will also not have any points. So A2 will also null. Now coming to A3. Now draw a circle for A3. So with radius of 2, then A4 is 25, it will not come, but A5 and A6 are root 2. What's the value of root 2? The value of root 2 will be, what is the value of root 2? Now A3 to A4 is root 25, which is more than 2, but the value of A5 is root 2, it is 1.21, which is less than 2. So A5 and A6 will come in A3. So A3 will have A5 and A6 in the neighborhood of, if I draw a circle for A3 with radius equal to 2, A5 and A6 will come within that, because they are having value of root 2 and root 2. Now you take A4, A4 will have only A8, because only A4 is within the radius of 2. Then for A5, A6 as well as A3. A3 to A5 is also root 2 and A5 to A6 is also root 2. So A3 and 2 is equal to A5 with radius of 2. A3 and A6 will come because their values are root 2. Distance matrix are root 2. So A3 and A6. Now A6, if you take A6 again, A6 what they will have? Root 2 for A5 and root 2 for A3. So A6 will have A3 and A5. Then A7, for A7 we don't have any values whose value is less than 2. So all are greater than 2. Then A8. A8 if you take, okay, only 2, root 2 for 4. So N2 equal to A8. A8 will have A4 within that cluster. So A1, A2 and A7 are the outliers. Now A1 is not having any points, that is outside the value of epsilon equal to 2. A2 is also outside, then A7 are also outside. So A1, A2 and A7, all these values are null. So these are treated as noise points or they are eliminated. While we have two clusters now. Now what we will have? We will have two clusters. One cluster, what is that one cluster? C1, which will include A4 and A8. A4 and A8. A4, A8, A8 and A4. So it will have one cluster C1 is equal to A4 and A8. Both will have the same values. Then second cluster will have A3, A5 and A6. A3, A6, A3, A5, A5, A6. If you merge all these three clusters, you will get second clusters A3, A5 and A6. Okay, so now if I draw a point for this, so A1 over here, which is null. Okay, so now A1 is here, A2 is here. What is the value of A1? So A1 is here, then A2 is also null, whose value is here, then A7 is here. What is the value of A1? 2 is to 10. What is the value of E1? 2 to 10 A1. Then A2, 2, 5, A7, 1, 2. But clusters A4 and A8. A4 and A8 in one cluster. What is the value of A4? 5, 7, 5, 8. What is the value of A8? 4, 9. Then A3, A5 and A6. A3, A5 and A6 if you take, A3, A5 and A6 if you take, that belongs to second cluster. A3's value is 8, 4. A6 value is 6, 4. A5's value is 7, 5. This is second cluster. Now if you increase epsilon equal to root 10. Now epsilon equal to root 10, additional points will increase, some points will increase. Now A1 to A8, what is the value? Root 5. So A1 and A8 will combine, A1 and A8 will combine with then A1 and A8. If I increase the value, similar fashion what I took for root 2, similarly if you scan for root 10, A1, A8 and A4 will come into one cluster, A2 and A7 will come into second cluster, A3, A5 and A6 will come into third cluster. So now coming to this is an example of how DB scan algorithm works out. So now coming to the next example of cluster evaluation. Why we need to evaluate a cluster? So why do we want to evaluate them? To avoid finding patterns in the noise. So we need to avoid the points that are the outlier points we need to avoid. So now to compare clustering algorithm, which clustering algorithm is performing well and which algorithm we need to consider. To compare two sets of the cluster, how they are being built, and to compare two clusters. Different aspects of cluster validation. So determine the clustering tendency of a set of data, that is distinguishing whether non-random structure actually exists in the data. So we need to find out why we need to go for cluster evaluation is that I need to completely distinguish whether non-random structures are present in the data or no. Comparing the results of a cluster analysis to the externally known results. Example, externally given class table. So expected value will given. So now when you evaluate the cluster, when you apply any clustering algorithm, whether the expected results are same as the experimental results, for comparing that we need to go for cluster evaluation. Evaluating how well the results of a cluster analysis fit the data without reference to the external information. Okay, then comparing the results of two different sets of the cluster analysis to determine which is better. So here comparing the results of two different sets of, so I apply two different clustering algorithms to the same data, then we will analyze to determine which is better, determine the correct number of clusters. Okay, so now for these reasons we need to go for cluster evaluation. So there are different methods for cluster evaluation. Supervised cluster evaluation using cohesion and separation. We are using the two properties cohesion and separation to evaluate the cluster. What is cluster cohesion? Is nothing but the compactness or tightness. Cohesion is nothing but tightness or compactness. How closely the data objects are in a cluster are tightly correlated or they are compactly present in a cluster, which determines how closely related the objects in a cluster are. Cluster separation, which determines how distinct or well separated a cluster is from other cluster. Cohesion is to determine how closely related the objects in a cluster. Cluster cohesion is how closely the objects in the cluster are closely combined, whereas cluster separation, which determine how distinct or how two clusters are well separated from other clusters. Then graph-based view of cohesion and separation. For graph-based cluster, the cohesion of a cluster can be defined as the sum of the weights of the links in the proximity graph that connects points within the cluster. Okay, the separation between two clusters can be measured by the sum of weights of the links from the points in one cluster to the points in another cluster. So how two different clusters are? So for a graph-based cluster, how cohesion is defined? Cohesion of a cluster can be defined as the sum of the weights of links in the proximity graph that connect points within the cluster. So here, how closely, so if I want to find out how closely the objects in a cluster are related, so we need to take sum of weights of each link in the proximity and determine how closely they are related. Then separation, if you want to determine the separation between the two clusters can be measured by the sum of the weights of the links from points in one cluster to the another cluster. Take the links, just find out how two clusters they are separated from one cluster, how two different clusters are separated. So mathematically cohesion and separation for a graph based cluster can be expressed using the equation cohesion for a cluster C of I, X for all belongs to C of I and Y for all belongs to C of I, proximity X comma Y, separation C of I. So this is for only one cluster. So cohesion will be applied for only one cluster for values X and Y, proximity of 2 points X and Y. So I need to identify for all the points in the cluster and check whether they are compactly or tightly connected to one another. Separation is applied between two clusters C of I and C of J. C of I and C of J are the two different clusters. Summation X for all belongs to C of I and summation Y for all belongs to C of J, proximity X comma Y. So this is cohesion. So where we are finding, so this is one cluster, so we are finding how closely these are the links that are connecting the different points. So how closely these clusters are connected to one another, that is cohesion. Then separation, now this point is connected to this point in three different possible, here to here, here to here and here, then here to here, here to here, three connections or 3 to 4 connections, three connections from one point to the another point. Take average of this and find out how differently they are connected. Okay, so now prototype based view of a cohesion and separation. Now prototype based, for prototype based cluster, the cohesion of a cluster can be defined as the sum of the proximities with respect to the prototype, centroid or median of the cluster. Similarly, the separation between two clusters can be measured by the proximity of the two cluster prototypes. So now here what we are doing, for prototype based cluster, the cohesion of a cluster is defined as the sum of the proximities with respect to the prototype, centroid or the medioid. So now with respect to center, take a cluster, find it out center. With respect to center, find out how closely the different other objects are closely connected to that cluster. Similarly, find out in between two different clusters, take the centroid of those two clusters and find out how they are separated from one cluster to the another cluster. So now in this case, cohesion again for all X of I, proximity X with respect to C of I is what? Centroid point. With respect to point X, I am going to center point. With respect to a center point, I am checking for all other points. Separation C of I and J. So now separation proximity, here I am not taking 2 points. So now here I am checking with respect to centroid. So here I am taking 2 points and checking whether those 2 points are connected or no. So but in this case I am taking a centroid point, and with respect to centroid point I am checking whether how they are closely connected. So separation between two clusters with respect to two centroids, so that is proximity C of I and C of J. Centroid of ith cluster and centroid of jth cluster I am taking and comparing how separately, what is the maximum distance, how they are properly separated. Separation C of I each. So how each separation of C of I, separation for a particular cluster, proximity C of I comma I with respect to each cluster, with respect to how many points in the same cluster are separated with respect to one another. So here the cohesion, prototype based cohesion. So with respect to this center point, I am going to find out how these points are correlated to this center point with respect to prototype base. In prototype base, what we are doing in prototype based clustering, how these 3 points are closely connected with respect to center point. Now in a prototype based separation, take two clusters, take their two centroids and measure how they are distinctly, how they are separated, what is the maximum distance between them. So how they are separated with respect to center, we need to find out in a prototype based clustering. So now measuring cluster validity via correlation. So take two matrices, similarity or distance matrix. So here similarity or distance matrix if I take, so there will be one row and one column for each data point, and entry is the similarity or the distance of the associated pair of points. So here, so one row and one column for each data point we will take, and we will enter the value into that table, the similarity or distance between the 2 points. Incidence matrix, one row and one column for each of the data point here also. In similarity matrix, in distance matrix as well as incidence matrix. In distance matrix also I am taking one row and one column for each data point, in incidence matrix also I am taking one row and one column for each data point. So here an entry is the similarity or the distance of associated pairs, similarity or distance between the 2 points, whereas in this incidence matrix an entry 1 is made if the associated pair of the points belong to the same cluster. So if the point belongs to the same cluster, I will include 1. If the point belongs to the other cluster or a different cluster, we will introduce 0. So the difference between distance matrix and incidence matrix is that in distance matrix one row and one column, in incidence matrix also one row and one column for each data point. Here the distance matrix or the Euclidean distance between the 2 points is entered to find out how two different points are correlated. But in this case, if the 2 points belong to the same cluster, we will have a value of 1, and if the clusters belong to the different points, then we will have it as 0. Now compute, now take distance matrix and incidence matrix, compute the correlation between these two matrices. Since the matrices are symmetric, only correlation between them is n into n by n minus 1 divided by 2 entries need to be calculated. So high correlation, positive for similarity, negative for distance. So high correlation, so if you will get a positive value for similarity or negative value for distance, indicate that the points belong to the same cluster or they are close to each other. So in a high correlation, so if similarity is more positive or the distance is more negative, that indicate that the points that belongs to the same cluster are closer to other cluster. Not a good measure for some density or contingency based cluster. So this type of evaluation is not good measure for some density or contiguity based cluster. Now supervised measure for cluster validity, external measure for cluster validity, two different kind of approaches. The first set of techniques use measures from classification such as entropy, purity and F measure. These measures evaluate the extent to which a cluster contains object of a single class. So here in this method we are using, so we use measures for classification. So in this method we are using different measures like entropy, purity and F measure to determine how a particular cluster contains an objects of a single class. The second group of method is related to similarity measure for binary data. So here we are using a measure called as Jaccard measure, which will be in the next part. So the second group of method is related to the similarity measure of binary data, such as the Jaccard measure. These approaches measure the extent to which two objects that are in the same cluster are in the same cluster and vice versa. So this approach, Jaccard measure, is to check the two approaches, so to which two objects are in the same class are also in the same cluster and are same cluster or they are in the same class. So this is enough for this video lecture. In next video lecture we will go for the next method, classification oriented measure of cluster validity. So in this video we covered DBSCN algorithm and different methods of cluster evaluation. Thank you one and all.